When we were last talking about the atomic theory, we said Thomson had come up with the first subatomic particle that was called the electron. And he said the rest of the material of the atom was made of positive, and that the electrons were just kind of throughout the entire positive material. About 10 to 15 years later, Ernest Rutherford comes along, and he does another experiment. Now, he's Thomson's student, so he's kind of on top of what's going on with atoms at the time. And he says, I'm going to conduct something called the gold foil experiment. Here's what happened.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
So when Rutherford was conducting this experiment, what he expected to happen was that all the particles would go straight through the atoms. Now, they thought this because based on Thomson's model, the density of the overall atom throughout the entire atom was pretty low, so the alpha particles should go straight through. But that's not what happened. What they saw was some of the alpha particles, not many, but a few of the alpha particles would get deflected off into different directions. He said it was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back at you. So once again, Thomson's model's on the top here, pretty low density. They thought all the particles would go through, but some of them were getting deflected. So this is what Rutherford came up with. He said some of the particles must have been getting deflected because there was something extremely dense on the inside, and he thinks that it also has a positive charge. So he named this very dense object the nucleus. He said that it's very tiny, it's very dense, and that it's positively charged. He said the rest of the atom is made of empty space, and in that empty space is where you have the negative electrons orbiting or going around the very tiny and very dense nucleus.